Okay, so once again, very good day to everybody. This is machine learning, and in this class, we discuss about the logical methods in classification. Actually, with the case of classifying data sets, we will be following a logical phenomena with machine learning, and we will be analyzing its models, how it is explicitly showing its behavior, how we should proceed to produce the processed results. Okay, so this is especially for you, my dear students and young researchers, and you can reach me at dr.christoananth@gmail.com. So before beginning the session, let me thank God for giving me this golden opportunity to deliver this useful session to share my knowledge among my fellow national, international participants, students, and young researchers. So in this class, we discuss about the classification, the major principles of classification in ML or machine learning, and we understand why this classification is important in machine learning. What are the classification terminologies? What are the algorithms with regards to classification? What are the advantages and disadvantages that we will be discussing? Then we discuss about the stochastic gradient descent method or maybe algorithm. Then we discuss about the decision tree. Okay. We discuss about the random forest model. Then we discuss about ANN, artificial neural network. Okay. So then we discuss about SVM, support vector machine. We discuss about how you try to evaluate the classifier. Okay. So I've already given the independent work in your Google Classroom. Please go through the Google Classroom. Please submit them. As I'm telling you, there will be 5 independent works and 1 open-ended project work. So you have to complete them as soon as possible. So at regular intervals, I will be giving you some short videos to discuss the knowledge in our topics. Okay. So this is classification, a short introduction towards classification. Classification means we are classifying maybe, okay, best students, medium students, bad students. We are actually classifying. So similarly, in the data, we are categorizing according to classes. Maybe we will have structured classes and then non-structured or maybe unstructured classes. Okay. So the process is nothing but starting out with predicting the class of given data point. So the class you will be designating it as target, label, or maybe some categories. Okay, some levels. So the classification predictive modeling is nothing but the task of approximating the mapping function from the input variables to the output variables. It is going to establish a relationship. Okay. So from there you are going to have a predictive modeling which is based on the classification. Okay. So the main goal is to identify which class or maybe which category the data will belong to. Okay. Fine. So maybe classification, why it is actually important in machine learning, that we will try to understand. So maybe let us take in the case some person has a heart disease. Okay. So we have to identify, we have to detect it. Okay. So this detection or maybe identification we can identify with the help of a classification problem, maybe like binary classification, where there will be two classes. The person is having heart disease, 2 does not have heart disease. Okay. So similar way, maybe if we have got a mail, there will be 2 things. One, in the Gmail. Okay, you receive an email. Okay. So one, it will be primary email. It is falling in the primary email. Okay. Or maybe it is spam. Somebody unwantedly they are sending the messages. It is spam. Okay. So this one you are going to classify based on the classification algorithm. So for this case we will use classifier. So it will be using or maybe it will be taking the training data to understand how the input variables are directly related to the class that you are specifying. Okay. So maybe classifier, if it has been trained properly, then it can be used whether the heart disease is there or not, whether the heart disease is present or maybe heart disease is not present. So this type is called as supervised learning. Okay, as I told you earlier in the first class, I told you supervised, unsupervised, and then reinforcement learning I discussed already. So this is an example of supervised learning. Okay, so the targets are provided with the input data and it is being supervised. Okay. So these are the classification terminologies. We will be having a classifier, which is an algorithm that is going to map the input data with its corresponding category. Then we have a classification model. The model is going to predict, or maybe it is going to draw a conclusion for the input data that is given for training, and it will predict which class it belongs to, or maybe which category it belongs to. Then you have feature. Okay, so it's nothing but the property of the phenomena which is being observed. And with the case of binary classification, we have two outcomes. Binary means only two outcomes, true or maybe false, 1 or maybe 0. Okay, then you have multi-class classification. So classification may be with two or more classes. So this one, maybe every sample is being assigned to one class. Okay, and maybe only one label, or maybe one target that you can assign to. Okay, so this is multi-class classification. Then you have multi-label classification. So every sample is assigned to a set of labels or maybe targets. Okay, then you have initialize. Initialize means generally it is going to assign the classifier, okay, to be used for the training purposes. Okay, then you have train the classifier. Every classifier in the scientific kit, okay, will be using a fit method, fit of x comma y method to fit the model for training the train x as well as train label y. Okay, right. So this is how it goes. Then you try to predict the target, which means that predict x. For example, there is predict x and then predict y. Predict x method is going to return the predicted label, which is y. Okay, and then evaluate, as I told you, like after doing all this one, we are going to test. We are going to evaluate the model. Okay, so maybe it will be giving like classification report, accuracy score, and so on. Okay, so this is the decision tree. For example, you are given with a job. Okay, you are in a confusion whether to accept the job offer or not. Okay, so maybe let us take in the case you have a salary. Okay, maybe at least $50,000 they are giving for 1 year. Okay, so you are having a decision. Okay, you are having a decision. You are having a salary of at least $50,000. So yes means again you are going to, maybe they are asking, can you work for more than 1 hour? Okay, then again yes. Okay, can you work for more than 1 hour? Okay, no. If you cannot work more than 1 hour, then they are also asking, maybe we are giving you coffee Vipul free, they are giving. Okay, so again yes means you are accepting the offer. Coffee no means then decline the offer. Or maybe if maybe commuting more than 1 hour, yes means then decline the offer. Okay, maybe salary at least $50,000. No, I don't want this. Okay, I want different one, which means you can decline the offer. So for each of the thing you are classifying. Okay, yes, no, binary terminology. Okay, each step by step. Okay, right. So these are the types of learners in classification. You call it lazy learners, dangasa, lazy learners. Okay, so lazy learners, they will simply store the training data. Whatever they are saying, okay sir. Okay, lazy. Okay, and wait until a testing data appears. Okay, so the classification is done using the most related data in the stored training data. So maybe they will have more predictive time compared to the eager learners. Eager learners, they will be thinking, okay, what idea can we do, how we can go for the test. Okay, they have more time because they will store just the training data and wait until the test data comes. Okay, let the test come, after that we will do. Okay, like that. Okay, so maybe the lazy learners, an example is KNearest Neighbor method, or maybe case based reasoning method. Okay, so these are the examples. Then eager learners. Eager learners means it will be having a classification model, just like a classification algorithm. It will be there based on the given training data. Okay, so it will be able to commit to a single model, a base model, or maybe a single hypothesis that will work for the entire workspace. For example, no matter you have 6 teachers, all the teachers, or maybe own teachers also, they will have the same strategy that they have to study, like that. Okay, so eager learners model, it's like a classification model. They will have a single hypothesis. It will fit into any of the entire space. Okay, so the example is decision tree, naive Bayes, and then ANN, artificial neural network. Okay. Then you'll have the classification algorithm. You have supervised learning method. You are basically going to organize the data into classes. Okay. So maybe like speech recognition. Okay. Recognizing your speech. Okay. For example, in the, as I told you, in the YouTube or maybe Amazon, you speak and it will be converted into text. Okay. And then face detection outside. Okay. Face detection. Handwriting recognition. According to the handwriting, it will take the characters. You call it as OMR, optical mark recognition. Okay. According to the characters that we write, it will extract from the handwriting. Okay. Then you have document classification. Okay. For example, if there are thousands, 10,000s of documents and it has to be classified, every time we cannot have human being to do all these works. The machine will do the work. Okay. So document classification can be this. So it can either be a binary classification. What is binary classification? 0 or maybe 1. Yes, no. Okay. Or maybe multi-class problem also. Okay. So maybe there are several algorithms, machine learning algorithms for classification even. Then we have logistic regression. Okay. So once again, it's a classification algorithm. Maybe it will have like one or maybe more independent variables to actually determine an outcome. So outcome is measured by the dichotomous variable. Okay, which means that there are two outcomes. Okay. So the goal is nothing but a best fitting relationship. We have to establish a very good relationship between the dependent variable and the set of independent variables. Okay. So definitely it is better than the binary classification algorithm, like maybe KNearest Neighbor algorithm, because every factor which has in this logistic regression will be leading to classification. Okay. So that is the advantage. So this is the advantage and disadvantages. So logistic regression, as I told you, again for classification in the best optimal way, and also it will be understanding the set of the independent variables that are taking place in the entire process, because only the independent variables will be affecting the outcome of this dependent variable. Okay, so that is the advantage we have. Okay. The disadvantage is that the logistic regression algorithm is that when the predicted variable is maybe binary, maybe 1 or maybe 0, okay, the data is maybe without missing values, and maybe it will be assuming that the predictors are independent of each other. So that is the problem. Okay, because we have to get this missing values. What are the missing data that is available? Only then you can classify them correctly. Okay. So these are the use cases, maybe for classifying words, or maybe for predicting the weather, okay, or maybe voting applications, or maybe identifying the risk factors for diseases, that you can use this algorithm or maybe method. And then we have names based classifier. Okay, so maybe it's a classification algorithm only based on the Bayes theorem. Okay, so go through the Bayes theorem if you do not know Bayes theorem. Okay, so maybe it will be giving an assumption of the independence among the predictors. So maybe names based classifier will be assuming the presence of a feature in the class which is unrelated to the presence of any other feature. Okay, so for example, if there are a group of objects, okay, we do not classify. So for this one, for a classifier, we'll have dog or maybe cat. Okay, p dog slash cat. Okay, multiplied by p of cat divided by p of dog. So maybe if we do a classification like this one, maybe we can separate the circle separately, diamond separately, and maybe triangle separately. Okay, so this is how it goes with the Bayes theorem. Go through the Bayes theorem, then you will have a mathematical formula that is associated. It will be a probability function to make an independent classification. Okay, right. So even if the feature depends on each other, which means that all the properties will be contributing to the probability independently. That is what I said, independence. Okay. So names based model, maybe it is used to make and maybe used the major advantage is that for larger data sets you can use for naive Bayes classifier. Okay, so naive Bayes classifier is used to outperform most of the classification methods in this machine learning. Okay. So this is the probability function P of Ci bar x1 to xn, okay, which is equal to P of x1 to xn bar Ci multiplied by probability of Ci divided by P of x1, x2 up to xn. Okay, this is the condition. Okay, provided the condition I lies between 1 to k. Okay, right. So this is the advantages and disadvantages. Generally it will require very small amount of training data even to get the parameters, to get the values of the parameters so as to produce the results, and definitely it is more fast, extremely fast compared to other classification algorithms. And but the disadvantage is that it's a very bad estimator, bad predictor. Okay, so that is the only disadvantage. Maybe for disease predictions it can be used. Document classification also it can be used. Spam filter, for example, in the emails that you receive. Okay, so maybe if somebody is asking, I want to I want to donate some $50,000 to your account. Please give me name, email ID, bank account number, your father name, your mother name. If they are asking means, then accordingly it will classify. Okay, the spam it will filter it out, and maybe it will put it as spam. Please don't click on the link. It will show. It is the message. The sender is not known. Okay, the message looks not safe. The message looks dangerous. Okay, like that it will filter. Okay, and then sentiment analysis based on how we try to speak, then it will actively get the results. Then you have the stochastic gradient descendant. Okay, so maybe it will be very effective and simple approach. Even maybe for the linear models you can use it. So stochastic gradient descendant is nothing but when the sample data, maybe again for larger data sets, when the sample data is very much large, then maybe you can use the stochastic gradient descent for actually fitting or maybe related to the linear models. Okay, so maybe for different loss functions or maybe penalties you can use it for the classification even. So you have a function g of w versus w, you have the global minimum to the initial weight. Okay, so maybe you can calculate the derivative for each of the training data that you are providing, and it will be calculating the update to that with the respect to the linear models. Okay, so the advantages and disadvantages. Advantage is that implementation is very easy, efficiency is very much obtained. Okay, performance is also very good. Okay, but the disadvantage is that it has a number of hyper parameters, and also it is also sensitive, okay, to feature scaling. Okay, so maybe for measurement of features, so it's very not really good. Okay, so that is the disadvantage. Maybe the new technologies like IoT, okay, Internet of Things. Okay, you can use it in the neural networks or maybe coefficients even in the linear regression. Okay, so that is the greatest application. And maybe you can also use K-nearest neighbor algorithm also. Okay, so as a K-nearest, if you can remember, it comes in the lazy learner. Okay, lazy learner, eager learner. So it's coming in the lazy learner. So lazy learning algorithm, that it will be storing all the instances corresponding to the training data in the n dimensional space. So just as you see in the diagram, we have red, green. Okay, so corresponding to that we have some circles. Okay, so it's nothing but a lazy learning algorithm. It does not focus on constructing the internal model, but it is going to just store nothing, just storing. The doctor gave notes. Okay, store, but not actually working on it. Okay, so it works on storing the instances of the training data. Okay, so classification is computed from the simple majority vote of the k nearest neighbor. So maybe if there are neighbors nearby, which means it is going to store it. Okay, so it is supervised, and definitely it will take a bunch of label points even, and maybe it is using them to label the other points even. So this is the K nearest neighbor. Okay, so we have category A, category B, and the new data point. Okay, so category A 3, it's nothing but neighbors. Category B 2, it is nothing but the neighbors. We have category A and B, and we have the new data point. Okay, so maybe to label a new point, which means that the label point close to the new point, you call it the nearest neighbor. So these are the nearest neighbors. This one, this one, these are the nearest neighbors. Okay, so it has the neighbor vote. Okay, so which means whichever label most of the neighbors have, maybe will be having the label for the new point. Okay, so K is nothing but the number of neighbors it is going to check, and it will be alerting, okay, that particular label to the nearest neighbor. So this is once again class A and class B. So we have the neighbors. We are going to find a new data point, and for this you are going to compute the neighbors which are nearby to find the analysis. So the advantages and disadvantages, it is actually very simple, but it is also much reliable even to noisy data. For example, if there is any noisy data, still it is robust and reliable. Even if the we have large data sets also, it is very efficient. The performance is also good, but the disadvantage is that there is no need to determine the value of K. Okay, so that is the reason the computation cost, the cost associated with the computation is very much high compared to the other algorithms. So the user cases, you can use it in image recognition. Maybe if you have to compare images, then you can go for image recognition, handwriting detection, video recognition, okay, stock analysis, share analysis, everything you can go with the K means nearest, K means nearest algorithm. Then you have a decision tree. Decision tree means it has a classification model, it has a tree structure. Okay, for example, let us go with an example. For example, you have a guest in your house. Okay, we'll ask questions. Did the guest eat chicken? Or maybe do the guest eat chicken? Yes or no? Chicken, yes, chicken boar means they are non-veg. No, they didn't eat chicken, chicken yolk. Then again you ask, did the guest eat beef or maybe mutton? Yes, which means they are non-veg. They say, did the guest eat mutton? No. Then again it will go. Did the guest eat seafood? Seafood means like fish. Huh? Fish, shrimp, like that. Okay. Yes. Again, non-veg only. Okay. No means veg. So we are doing decision trees. First chicken, then mutton or beef, then seafood. So every step, yes, no. Non-veg, veg. Okay. Correct. So maybe it will be utilizing the if then rules. If this one, then this one. Okay. So which are equally exhaustive and maybe mutually exclusive in the classification. Okay. So the process, it is divided into substructures. Okay, and it will be associated with the incremental decision. Okay. So the final structure will be having a tree with the end node. We will have the nodes as well as the leaves. So the rules are applied one by one by order sequentially, okay, using the training data one at a time. And every time a rule is learned, the tuples covering the rules are actually removed. Okay, so next step it will go. So previous it will be removing. So the process continues on the training set until the termination point is actually met. Okay, so it is actually top down. It is not bottom up, but top down recursive divide and conquer approach. Okay, so the decision node will be having two or more branches, and the end you call it as a leaf. Okay, so it will be used for representing a classification or maybe decision. Okay. So the topmost node in the decision tree that corresponds to the best predictor, you call it as the root node. And the best thing about the decision tree is that it can handle both the categorical data or maybe some data associated with the category and numerical values, numerical data also. So the advantages and disadvantages, generally it can understand and visualize. Maybe it requires little data preparation. Okay, but disadvantages, it can create complex data trees that may actually bore the categorization process much more efficient as well. But disadvantage is that it is very unstable, because very small change or maybe simple change in the data can disrupt the whole structure of the decision tree. So maybe you can use this decision tree for data exploration, maybe for pattern recognition, for identifying a pattern, and maybe for pricing in the finance sector, or maybe identifying the disease, or maybe what are the risk factors, risk threat, maybe problem that will happen, that you can use the decision tree, whether this or that. Okay, are you coughing? Yes. Okay, you are coughing. Okay, again, injection. What is the result? Positive, negative, negative. Okay, negative means okay, no problem. Positive means okay, COVID sick. So everything. Okay, you have lung problem. Yes, no. You have to take blood test. Blood test, more amount of sugar. Okay, you have sugar problem. From that, step by step. Okay, so this is identifying the disease and maybe risk threat also. So this is random forest, random decision trees, or maybe random forest. It's nothing but a learning method, ensemble learning method, maybe for classification, for regression, for mathematical analysis, or maybe mathematical regression. You can use the random forest. Okay, so maybe you can construct a, a number of decision trees at the training time, and maybe the output of the class, it's a mode of the classes, or maybe classification, or maybe prediction, which is nothing but regression. So meta estimator, it's a random forest, maybe for a number of trees that we will be having the subsamples of the data sets. Maybe you can use it as an average to improve the system's efficiency and performance. Okay. So the subsample size is almost the same as that of the original input size, but definitely the samples are actually obtained with the replacements. For example, here you see all data, we have subsets. One tree half, one tree full. Like left hand side is there, full is there, right hand side is there, and only from that you will be getting the characteristics. Okay, so the advantage is that it's very accurate, okay, with regards to performance than the decision tree. Okay, this method random forest is very much accurate, okay, because it is having the reduction of the overfitting policy. It is going to cut left, right, middle. Okay, so that is how it goes. So disadvantage is that it is with regards to implementation, it is quite complex, and of course for real time prediction it is very slow. So that is the disadvantage. Okay, so maybe if you can say like a user or maybe application cases. Okay, so maybe if suppose if you are a bank manager and maybe some person is coming for asking loan, maybe he will have good motive, maybe he really wants money, or maybe he want to cheat. So maybe the high risk or maybe low risk, okay, about the loan applicant, that the random forest will be identified. So that is the reason it is having a complex implementation. Okay, and also for predicting the failure of the mechanical parts, maybe the automobile engines, maybe mechanical parts is having some problem or maybe failure, that it will be identified. And also social media share scores. For example, your post, this many it is performing very good. Okay, your video very good, your business not good, everything it is predicting how it is sharing, how it is performing, that you can do that. For example, you have like Facebook analytics, you have YouTube analytics, yes, Instagram analytics, everything the social media shares, that random forest will be doing them. Okay, and then performance scores you can identify, we can predict much better with the case of random forest. Then you have ANN or maybe artificial neural network. Okay, so maybe a neural network will be having number of neurons which are arranged in layers. Okay, so maybe they will be having an input vector, and this input vector should be converted to the output vector. Okay, so for this one the process will be having every neuron which is taking the input. Maybe you apply one function which is nothing but a non-linear function. So for example, these are the inputs x1, x2, x3, x4 up to xn minus 1, xn. So everything is added. This is the weighted sum, and from that, okay, you apply a bias, okay, an external bias you apply, and from that you apply the sigmoid function. One nonlinear function is being applied to convert it to the output. Okay, so everything performs in the next layer. So it is having feed forward also, feedback also we will be having. Feed forward means everything, okay, to the output. Feedback means to the input. Okay, so maybe feed forward means the unit or neuron feeds the output to the next layer, but there is no involvement of any feedback to the previous layer. So that is the thing. Okay, and maybe weightings are applied to the signals from one layer to another, and maybe weightings are tuned in the training phase to adapt a neural network for any given problem statement. So advantages, you can say, like it has higher tolerance of noisy data, and maybe if there are untrained images or maybe patterns, that it is going to classify. Okay, so maybe with regards to continuous values input or maybe output, it is going to classify the untrained pattern. Okay, but disadvantage is that it has a very poor interpretation of results compared to the other models. Then you have SVM, support vector machine. Okay, so here we will be representing the training data as points, as different points in space, which are separated by the categories. Okay, the categories will be having a gap, a small gap. Okay, so every new point are then added to the space by predicting which category it will fall into and maybe which space it will have. Okay, and every gap should be as wide as possible. Okay, so maybe it will have a subset of training points in the distant function. Maybe it will make the memory much more efficient as well, and even in the higher dimensional space it is very much useful. Okay, but disadvantage is that it will not directly provide the probability estimates, so that is the only disadvantage. So you have the margin, you have the hyperplane, and then you have the support vectors. Okay, if you can see, the gap is wide as possible, and through this you are having the efficient performance. So maybe for the performance of stock, how the stock is performing, that you can classify. Okay, or maybe investment suggestions, where can you invest? You have more money, but where to invest you don't know. Okay, so for suggestions for investment it will be giving, and maybe because of based on accuracy or maybe efficiency, this method is very useful. SVM, support vector machine. And then finally you have classifier evaluation. So final part is like for the completion of any classifier, you have to check its accuracy and maybe efficiency, and there are a lot of methods to evaluate a classifier even. So we have a holdout method even, so that is a very common method. So maybe the data set is actually divided into two parts. One is a test and another one is train set. Okay, test set, train set. Test set is 20%, train set is 80%. Okay, so train set, it is going to train the data. Whatever data is fed to, it will be going through the training algorithm, and maybe an unseen test set will be used to test the predictive part that is associated. For each of the data that we are passing, it is going to test the unpredictive part. Only with the unpredictive part only we can be able to get better performance and efficiency. Then you have cross validation. Okay, so maybe you will have the problem called as overfitting that is present in most machine learning models, and that is the reason you cross validate the process. Okay, both the inputs you cross validate. Maybe you will have like k-fold cross validation even. Maybe if the model, maybe if it has the overfitting problem, then you go with the two-fold or maybe three-fold or maybe k-fold cross validation strategy. Okay, so this is the data set. Okay, so it is divided into k exclusive subsets even. Everything will be having same size. Okay, so out of these, one is used for testing and another one is used for training. Okay, so for each of the fields, maybe two fields, two types. Okay, so it is being tested out for k number of fields. For example, the data is coming means you have training, testing. Okay, fold to testing comes, test. So every fold we are actually training, testing. Okay, test will we approaching, okay, and the average of that will be used as a final measure to measure the performance. So this is the independent work, decision tree, divide and conquer, okay, complex strategy, ID3 algorithm, achievements and disadvantages of the complex strategy, problems of retraining. Okay. So what you do, you please complete them in your Google Classroom.